Okay. So now you're talking about, deep learning, and you can see deep learning is subset of machine learning. So machine learning is subset of AI. So we have covered machine learning, and deep learning is part of machine learning. That means here also we have algorithms. Okay, just like you have algorithms for machine learning, and most of these algorithms are supervised algorithm. Okay, so the advantage of deep learning, or the way deep learning is different, is based on, okay, is the way we actually use the algorithm. Okay, so see, so far, okay, we were talking about, if you look at in terms of layers, we all the algorithms that we did had just one layer. You have input, you have an algorithm, you provide the input to the algorithm, you get an answer, you get an output, right? Whether it is regression or classification, you get the answer. But sometimes problems are not that simple. Like if you have to analyze audio, video, images, right? Then your one layer machine learning algorithms will not be useful. So what we do is we use machine learning algorithms where we run multiple layers. So the deep learning, okay, the concept of deep learning is that you have multiple algorithms built into the system which runs multiple time. Okay, so the like if, for example, if you talk about aeroplane, we say aeroplane is designed um, based on bird, right? How bird flies, but it's totally different, right? Concept is based on bird, but it is nothing to do with bird. It has nothing of bird thing into it, right? Similarly, we say the deep learning is based on neurons. So, right. So let's say if somebody pinches you on finger, the message goes to brain. How does it goes to brain? How does it go? You have multiple neurons, right, which is connected to each other. So the moment something happens on finger, the neurons will start passing information, and then it goes to the brain. So on that concept model only, the deep learning is created. Deep learning says, okay, we'll create multiple layers. Okay, and each layer will have input. Okay, and then we will add some bias into the system and we'll get an output. So you have input, you apply a function and you get the output. Now this output will again goes as input to the next perceptron. We call them as perceptron. Each layer is called perceptron. So perceptron is like neuron, okay, and each perceptron is like layer of mathematical model in itself. Okay, so if you talk about example here, okay, so let's say we are solving a problem. You have variables x1, x2, x3, which can take infinity plus infinity to minus infinity. You can take any value. Now you assign, okay, weights to it. Okay, so you have variables which are your input, and input can be any number of variables, isn't it? If you have 4 columns, you get 4 input. If you have 10 columns, 20 columns, 50 columns, then these 50 are your input to your machine learning model. Okay, so you can have any number of variables and the values that it can take in, and then what we do is we assign some weights to each of these variables. So your perceptron has two things. Perceptron has weights and the activation function. Okay, so perceptron has weights and activation function. Now, when you provide the input to it, not all input will have same weights. We have seen, right, when we talk about correlation, some are more correlated, some are less correlated, right? So when you take the input, the ones which are more correlated should have higher weights than those who are less correlated, right? So the perceptron, okay, or your model actually tries to give weights to each of these variables. Okay, now it starts assigning its own set of weights, and okay, that's where the training data is for. Okay, that's why I told you machine deep learning is mostly based on supervised learning. Okay, so it takes the input, okay, it takes the output, it tries to add different weights to it, and then compares the output. Okay, if the output matches, that means your weights are perfect. Otherwise, you have to go back and change the weight, and we'll talk about it. But now let's focus on what are the components of a deep learning. So you have input variables, then you have to assign weights, as weights are assigned automatically by the model. And then you have a decision. Okay, so after assigning weight, when you want to get the output, okay, what should be the output? Okay, so based on the output, we have activation function. Okay, and later we'll talk about different types of activation functions. So it applies activation function on your input values, and this activation functions gives an output. So activation function is designed. Okay, we have seen one activation function so far, sigmoid. When we were doing logistic regression, we saw the sigmoid function. So what does sigmoid function do? Do you remember? Whatever be your input, it classifies, or the output of sigmoid function is 0 and 1 only. So for example, you put a threshold X. Anything less than X, okay, is assigned 0. Anything more than X is assigned 1. So no matter what input you give, output is always 0 and 1. That's the job of sigmoid function. So if you want to predict, let's say, classification kind of problem, the last layer, last perceptron will have activation function of sigmoid. But in between, you can have other sigmoid function. Okay, so depending upon the type of output you need, you will use activation function. So, okay, so input we provide, weights are assigned by the algorithm. That's the purpose of algorithm. And activation functions also we can decide, or it chooses its own activation function. And then you get a Y value, output value. So this is how one single perceptron works. Okay. So that is how one single perceptron works, and which is very much like our machine learning. So one single perceptron is like machine learning, right? So that's what we did, right? When you say Y equal to in linear regression, mx m1 x1 plus m2 x2. So we assigned m1 and m2 as the weights, correct? Okay, and we applied a function, okay, which gave us those weights, right? Now, when you repeat this multiple times, that's when it becomes deep learning. So if you see the example here on this slide, you have input car, we have feature extraction. So what we do, we extract the features. What does mean of feature extraction? Each component, right? Okay, we look at each component and then we run our classification, and then you learn, then you get the output whether it is car or no car. Deep learning does not have feature extraction, or you can say that we don't do feature extraction. Algorithm automatically will do the feature extraction. So the deep learning does, okay, the feature extraction. So see, if you see the way the machine learning works, okay, you have input, the hidden layer, we call that hidden layer, okay, the processing layer, okay. So you have input, processing layer, and output, okay, just one layer. Here you have input and output, of course, but you see there are two layers in between. That means these two are processing layers. So you can have multiple processing layers in between. Okay, so in first case, human intervention is required, but not in second case. Okay, but it uses unsupervised learning. It uses the training data to change the weights. Automatically, it will change the weight. Okay, so that's why it is easier and better than your machine learning, right? Here, it uses its own calculations to assign the weight. There, we have to give the parameters, right? If you remember SVM, support vector machine. So we had to give there the model that we want to learn, whether it is linear or polynomial, or whether it is our radial bias function, right? RBF. Then we give all those parameters. Here, okay, those parameters are not required. There still it needs some parameters. We'll talk about it later when we get into details. But let's understand how this works. So if you see, okay, deep learning is implemented using neural network. There are other types of deep learning, but let's focus on neural network. Okay. So here you see you have input data. Okay, on the screen you see the blue dots are your input layer, correct? You provide the input. Then you have multiple hidden layers. Those orange dots in between, those are your multiple processing layer, or we call them as hidden layer. Okay. And in this example, there are three. You can have two. Generally, we have at least two. That's why otherwise it becomes a machine learning only. So you have, multiple hidden layers, and then you get output layers. The output layer, would be begin based on your expected value, what you want to get. If you're talking about regression, you will have multiple output layer. If you talk about, you have only one output layer, which is the calculation based on input values. When you talk about binary class, you'll have two output. When you talk about multi-class, you will have multiple output. Okay. So output for regression will be only one. Okay. For multi-class, so this looks more like a multi-class. Okay. You are classifying values as one out of these four. Okay. So this pattern is done without human intervention. Okay. So this is also called as feed forward. Okay. Feed forward means you're taking the input, you're assigning weights, you're running activation functions. Okay. So every hidden layer assigns weight, and every hidden layer assigns activation function. Okay. So, and then you get an output. Okay. So this is one way, right? It is one way. So the basic form of neural network is only feed forward. Okay. So that means data is taken as input and processed, and you get the output. Some algorithms, it actually does the back propagation also. That means once you get the output, it checks the output with the training data, and based on that, there'll be adjustment in the weights, and it takes back and gives input again. Okay. So advanced algorithms will also have back propagation built into it. That means it will take the output, your output from the algorithm, it will compare with the training data, at least what you have to do is making the adjustment in weights. That's what we are doing here. So it goes back and feeds again back to the input. Okay, it goes back again. So, okay, so it's like this. Okay, you perform something and you see the output doesn't match, then again you go back and changes the numbers, right? Okay, so back propagation is lengthier, longer, time consuming, but it is going to give you the correct output. Now, sometimes if you do too much of back propagation, right, you might end up into what is called as what kind of scenario? Overfitting, right? You're overfitting the training data, and you might miss the point on the test data, right? So, but yes, back propagation is more accurate, better than just feed forward. Okay. So these are the components that we have seen so far. Layers. So you have input layer, okay, hidden layer, or also called as your processing layer. The actual processing happens in the hidden layer. And finally, the output layer, which is C. So input and output is what we see. That's why we say hidden layers. Okay, this is the process. So for example, and if you look at human being also, this is what happens, right? If I ask you, what is 3 plus 5? So 3 plus 5 is the input that I'm giving you. You give me 8. But the calculation happened in your brain, right? Calculation happened in your brain, which we don't see, right? So that's why it's a processing layer or your hidden layer, right? So if I ask you simple question 3 plus 5, probably you will not even think twice. But if I ask you some complex question, right? So you will get an answer, but before you tell it an answer, you will again go and revise. You will revisit and see if your mind is, the answer that you have got is correct or not. That back propagation, right? So you say, okay, answer is 8, but is it 8? Okay, you will again do something. Now, if I ask you, for example, okay, if I ask you how many people, for example, or let's say probability question I ask you. So if I ask you a probability question and your answer is 1.2, you'll revisit, no, probability cannot be 1.2. That means I have done some mistake. I have to go back and, so you are again recalculating. Okay, the first method that you use probably is wrong, right? Is wrong, obviously, because you can't get probability more than 1, right? So you go back and again, so that's a back propagation, and finally you give an answer, right? Answer can be wrong also, right? So that's why I'm saying that machine learning or deep learning doesn't give you 100% answer. Okay, and but thing is, we want as high accuracy as possible, right? So you have input layer where you take the input, you process, okay, and it can be multiple layers. Okay, so there will be multiple hidden layers, and finally one output layer. In the hidden layer, write two things. Your weights and activation function is applied. So weights and bias we say. Okay, weights you assign, and we also assign bias because weights alone will not help. Okay, weight is what we multiply to the input, right? To make it balance, okay, we also apply bias to it. Bias is a additive term, right? You add some bias into it to make it, okay, so the output of this is going to be similar to your training data, right? That's why we provide training data to learn. So bias and weights are changed continuously to match the final output. So weights and bias are applied, and also you have activation function. Activation function is the function which actually does the calculation. You apply the weights and bias, but what would be the output? So output has to go through this activation function. Okay, and this process, the hidden layer process repeats, and finally output layer, you get the output. So these are your four basic components. And some algorithms also will have back propagation, which is come back and optimize the weights and bias again, you know. So you go back, so the output that you have got, you go back and change the activation, the weights and bias. Okay, you go back and change it. So that is done using back propagation. Okay, so this is an example of your sigmoid function. Activation function, there could be multiple activation functions. Most commonly used is sigmoid, which is used for binary class kind of analysis. Okay, so model is predicting your probability. Okay, and the probability is either 0 or 1. So you see the equation is 1 by 1 plus e power minus x. That means, so you'll have a, you see my cursor here, right? You'll have some some value here, okay, which tells you the cutoff kind of. So anything less than this, you'll be classified as 0. Sorry, what happened? Anything less than this will be 0. Anything more than this is going to be 1. Okay, so this is your activation function. Here is going to return only 0 or 1. Then there is another important function which is called threshold function. So threshold function does not even have probability. Okay, so in sigmoid again it is 0 and 1, but based on probability, right? You'll get some probability, let's say 0.5 or 0.4, and you'll set a threshold. Threshold is like, okay, threshold is like if your value is, let's say, more than 0.5, classify as 1. Okay, value less than 0.5, you classify as 0, right? So you are still calculating the probability, and then you are classifying this as 0 or 1. But your threshold function, okay, it does not calculate probability. It is, if value is more than this, it is 1, less than this is 0. So there is this line that you see is straight line, right? It does not, it's not like S in the previous case, right? So in this case, if you take, okay, if I take this to the paint and then talk about it. Let me switch back 1 second. So see here, this is 1, right? From here, you might say 1. Okay, this is 1 and this is 0, right? But between from here till here, we cannot say it is 1 or 0, right? Now, these are closer to 0. If they are closer to 0, you can still classify them as 0. You can still classify these as 1, let's say, closer to 1. Okay, but see, it's not exactly 1, right? But between this area, okay, it is difficult to classify, right? So that's why you give a threshold. Threshold is, let's say, 0.5. So 0.5 will be somewhere here in the half between, right? Somewhere here between. So you say, okay, value, if this is less than this, will be 0, and more than this, it is 1. So, but the activation function is calculating probability, and based on the probability, you are classifying. But this one straight away, okay, which one? Threshold function, okay? Just have a straight line. That means anything less than that line, anything less than that line is 0, anything more than that line is 1. So you have one function is threshold function. Then you have ReLU. Okay, hidden layers uses ReLU by default. Okay, so output layer uses sigmoid function, but most of this, okay, it is most used function, which is your ReLU function called as rectified linear unit function. Okay, it gives you 1 and 0, but anything between 0 and 1 is also possible. Anything between 0, so it's giving you probability, and it can take any value between 0 and 1. It can take any value. Minimum is 0, maximum, okay, is set as 1. Okay, maximum is set as 1, but it can take any value. Okay, so that's why it says it is maximum of x comma 0. Okay, I mean, see, when you apply 1, that means there is there is no activation function, right? If you say 5x into 1, so it is 5x only. Okay, so it uses any value between 0 and 1. So if you are doing regression kind of example, ReLU is used, and hidden layers mostly uses ReLU function. So this is your one activation function. Then you have hyperbolic tangent function, fourth function we're talking about. Okay, so this again has this again is like sigmoid, but difference here is that in sigmoid the values are between 0 and 1. Here values are between -1 and +1. So here values can go to -1 also, negative also. So values ranges between -1 and +1. Okay, so whatever you give as input, it will give you output something in between 0 and 1. Okay. Okay. So how does a simple neural network works? Okay. Let's understand this function. Now, so far you understood, right? So what is deep learning? Okay. What are the components of deep learning? And we discussed about top 4 activation function as well. Yeah. Now, this is an example, okay, where we're talking about how a simple one layer neural network works. Okay, and if you understand, the same concept is applies, okay, over multiple layers. So let's say, okay, you are looking at a dosage, okay, okay, and the dosage can go from 0 to 1, right? So your dosage of, let's say, you need to take paracetamol, okay, and doses can be 0 to 1. But what is the right amount of dosage? Is it something, it will be between 0 and 1? Okay, so you take a dosage and then you apply this, the weight here. Now you see, okay, the weight that we have applied here is x, okay, x minus 34.4 and 2.5. Now, these are the weights that we applied automatically. So these are the weights, okay, and then let me use pen here, I guess. Okay, so this is the weight that we have applied, and this is the bias. This is the weight and bias, and then we apply through this equation, and finally we add them together, and you get, okay, minus 0.58. Okay, this is one layer. Okay, you take the input, okay, you took it through the activation function, and you get this value here. Now, if you provide, so that was the setup that we did. Now you pass these values between 0 to 1, right? 0 to 1. So if you start with 0, so what happens if you do 0 minus 34.4 and add 2.4, okay, to this, what happens? So left side you apply 0, okay, and what you get, okay, so it is 0, right? X is 0, right? So you applied through this activation function, which is called as soft plus function. What you see here is soft plus. Now, soft plus, what it does tell you that the negative side, it goes to 0, but positive, there is no end to it. Okay. So finally, because this is x into, okay, minus 34.4, so this becomes 0. and you're adding 2 to it. So it is f of 2.14, f of 2.14. Okay. Or if you apply through a sigmoid curve, if you apply through a sigmoid curve, it becomes f. Okay. So that's what, so you can take any function here, right? So you can apply soft plus, you can apply sigmoid. Okay, this is ReLU equation. Okay, so apply ReLU function over here. Okay, and okay, so you figure out that this is the value on okay, we'll take soft plus and check. So if you apply soft plus, this is the output of the soft plus function. Okay, so this will give you some output. Okay, so this will give you some output. Okay, now, okay, so this is, see, we had two values, right? So this is your first side. Now your value will range from 0 to 1. That's what the dosage is, right? From 0 to 1. Okay, and so you will increase the value from 0, then 0.1, 0.2, 0.3, right? And you get corresponding y-axis values here. So you see, if I apply from 0 to 1, this is the curve that I'll get using soft plus. This is what you see. This is the output that you're going to get. Okay, so this is the output of the top part. Now, similarly, we have to do for the bottom also. So, okay, so we took weight as minus 2.52 and we are adding a weight of 1.29, correct? So again, we have to apply different parameters. And if you do from 0 to 1, this is what we are getting. So, okay, so this is the output that we have got for 0. Now, this is what we are getting for 1, okay, from 0 to 1. Now, if you overlap them, okay, so see, so this is for the x value is changing like this, and this is your y value. If you apply both of these together, okay, so this is what you will get. Okay, and finally you're getting an efficacy of 1.03. Okay, so what you do is, efficacy is what we need, about 1. Now, if you apply it, if you run it multiple times, it shows that dosage of about 0.5 is what is 1, right? So in this case, you will know that, okay, dosage 0.5 is better. Okay, now see, you can do the calculations with it later, but what I'm trying to show with this example is that, how the deep learning works, right? It applies those activation functions, applies different weights, and then it compares efficacy, and efficacy is one that we need. Okay, so it will say that, okay, 0.5 is best, gives you the best efficacy, right? And then this is repeated multiple times. This is repeated multiple times. Okay. When you build a neural network, you need to decide how many hidden layers you need and how many nodes to go in each hidden layer. So, okay, so we have seen one hidden layer, okay, which is good. Now the problem, one example. But see, input is decided. Input we cannot change, right? Input what we provide, and output is also decided based on your objective. Okay, so input and output, there is no problem. The problem here is you have to decide how many hidden layers to create, and also how many nodes should it have, right? So when you provide 5 input, how many those 5 input, okay, through the activation function or through the hidden layer, how many nodes should we put in each hidden layer? So these are the 2 parameters, and of course there are other parameters also which we need to understand, or what you call, when we say that we are improving the model, this is what we need to decide, how many hidden layers and how many nodes should go in each layer. Okay. Okay. So how do we train a neural network? Okay. So here you see, get the output using activation function. But this is the last step. First step is calculation of the error. So you perform, you run the model based on whatever is your judgment, and based on the judgment, you calculate the error, isn't it? So error is on the higher side, that means you have to reduce the value. If your error is on lower side, to increase the value. That's what is done by updating weights and bias, right? You have to update weights and bias. Then again, you make prediction using new values. Okay. And then you have to add layers. Okay. If one layer doesn't, obviously it will be more than one layer. So if two layers doesn't work, then again you have to add one more layer. Okay. Then again you calculate the weighted values. Okay. And then you look at the output. So basically what we are doing is you are changing the number of layers, you are changing the weight and bias to match the training data output. Okay. You have to keep doing it till there is a match. Okay. So what I'll do is I'll stop here. This is the basic of neural network. Did you understand? This is, how the neural network works. So neural network purpose is to find number of hidden layers, to find number of or the type of functions that has to go in making those prediction. Okay. Now we will talk about one specific example, which is called ANN, artificial neural network. Okay. So we will extend that basic knowledge to make one application. Okay. So, but before we talk about, the example itself, we need to talk about different software that is used to. What we just did is basic, understand the deep learning. Now to implement it, you need software, right? So there are two main libraries which we use. We use scikit-learn for machine learning, right? So here we have, in fact, three main things. Okay, you have Keras, you have TensorFlow, and you have PyTorch. Okay, so Keras is a pointer again. So Keras is a high-level deep learning API. Okay, and it is written in Python only for your neural network, right? For deep learning analysis. Now TensorFlow is designed by Google. Okay, it does the same thing what Keras does. Okay, and it was designed by Google. Google used to use long time back, and few years back they made it public. Okay, they said, okay, now you guys public can use this. So TensorFlow is available. Then PyTorch is similar to TensorFlow and Keras. Okay, but it has a lot more advanced features. So if you are dealing with computer vision or natural language processing, then PyTorch is the preferred one. Okay, so PyTorch is again the one developed by Facebook and they made it public. Okay, so the good thing is TensorFlow you can use PyTorch along with TensorFlow without any problem. Okay, so Keras focuses on user-friendly and extensible features for handling deep learning activities. Okay, and this is also available. Okay, the beauty of this is also available with your TensorFlow, right? So TensorFlow has a module called TensorFlow.module Keras. So Keras module has inbuilt into itself. So that's why you can say that your CNTK was developed by Microsoft. Okay, so these are the libraries to work with Keras. And since Keras is available in TensorFlow, that's why we generally prefer TensorFlow module. Okay, and Keras is inbuilt with it, so you can use it without any problem. For PyTorch, we have to use Keras separately. Okay, so if you are using TensorFlow, you don't have to worry about Keras. Keras is automatically available. Okay. So you can use either PyTorch or TensorFlow, and I recommend to use TensorFlow only for now. Okay, you use TensorFlow for your analysis. Okay. Now, okay, so you have multi-layer perceptron. Okay, as the name suggests, you have multiple layers, right? So you have one input, one output, or more than one hidden layer. Okay. So this is what we see or what we know about deep learning model, right? So this is like neural network. Vanilla neural network means one layer, but then you can have multiple hidden layers, right? This is what we discussed. Okay. Now, what is ANN? So ANN is the first model that we're talking about. It's a group of multiple perceptrons or neurons at each layer. Okay. ANN is also known as feed forwards. I told you, right? Not all uses back propagation. So ANN is only feed forward. It does not use back propagation. Okay. And this is the simplest of all the algorithms that we have. Okay. So there's an example here, which I'm going to give you the link. Okay. We are not going to do that in the class. Okay. You can take the link and you can practice this on your own. Okay. So this is an example. Okay. And these are the columns that data set has. Okay. And then, we will take these parameters for our input. This is the sample data that you see. So you have customer ID, surname, credit score. Okay. And what our objective is to make. Okay. So let's go back here. Okay. So these are the characteristics of your customer. And then you'll see if they have left you or not. Exited 1 means they have left you. 0 means no, they have not left you. So we are, based on these characteristics, we are trying to find, okay, that will customer leave you. So we are trying to predict the type of customer who will leave us. Okay, who will leave us. So who are the customers who have higher chances of leaving us? So once you know, it's up to you whether you want to, address the question them before, right? So you know that these are the potential customers who might leave us. So you go back, talk to them, and try to, help them so that they don't leave you. Correct? So but model will only tell you yes or no. Okay, these are the type of customers who might leave you, right? So one are the people. So in the training data, one is that they have already left, right? 0 is they're still with you. But model should predict based on which characteristics and the customers who are still part of your business, but they might leave you, right? That's the objective. Now this is very similar to your classification. This is classification problem, right? But we are not using machine learning model, but we are using deep learning model. So when we say that we are using deep learning model, that means we are using some form of neural network, right? So algorithm changes, the concept remains same, right? And this is an example which, you can practice. I'm not going to do it in the class. Okay. So here you see, okay, let's go step by step. So of course, you need to import pandas and numpy, and we will use TensorFlow because in future, in going ahead, we are going to run ANN, right? So instead of using scikit-learn, we are using TensorFlow. Okay, so reading the data, this is how you read the data, right? It has a categorical data, so you have to use label encoder to get it done. Label encoder, column transformer, one hot encoder to handle the categorical data. Okay, then you divide into training set and test set, right? So we are saying test size of 20% or 80% of the data goes as training. Okay, we need to scale the data. Now see, these are the steps that we did before also, right? So the pre-processing exactly same. Okay, only change is when you start running the model. Okay, now we need to initialize ANN. Okay, we are using ANN now, so we'll have to initialize ANN. So ANN we say TensorFlow.keras.models.sequential. Okay, so very first step while creating ANN is to create a object, ANN object. Okay, so as part of TensorFlow 2.0 is used, and Keras is now integrated with TensorFlow, so you don't have to worry about Keras separately. Okay, now you have to create hidden layers. We have to create hidden layers. So yes, see this is so first initialize the ANN. Now we are creating hidden layers. So how many hidden layers have we created? We have created 2 hidden layers. How many, what are the number of nodes that each of the hidden layers has? And what is the activation function? So see, we are creating 2 hidden layers. ANN.add, okay, dense. So when you see this layers.dense, then we are adding hidden layer. And in the hidden layer, we are giving 6 units to them. Okay, and we are saying activation function is ReLU. Okay, so we are giving ReLU and we are giving activation function. These are the values that we are giving. Now, if you ask me, how do we decide? We have to run it and see. We don't know, right? we don't know whether this is correct or not. You have to keep running multiple times to see the perfect value. Okay. So there is no hard rule about number of neurons that should be present in the layer. Okay. And later we'll talk about, the optimal things. And okay, maybe tomorrow we'll talk about how to optimize your network. So for now, there is no hard rule. Okay. And we are using ReLU function. Okay. So generally, okay, 90% of the time, we use ReLU function only for hidden layers. If you have some strong reason why we should use some other function, then only you use some other function. But hidden layers uses ReLU, because if you remember what does ReLU does, it creates the probability between 0 and 1, right? So that's what we want. Okay. Of course, your output layer will have specific function based on the kind of output that you're predicting. But the hidden layers will have 90%, 10% I'm saying, because if you already know, okay, there's some special case where you need to know, okay, but otherwise you will allow it to give values, any probability between 0 and 1. Okay, so we use ReLU function for inbuilt. Okay, and finally you add another layer, okay, which is called output layer. So the last layer that you add, okay, will have 1 unit. Okay, now 1 unit, because it is, we are using yes or no, right? So one output is enough to tell us yes or no, and you're using sigmoid. Sigmoid will give you 0 or 1, isn't it? So it will tell you 0 means customer will not leave you, okay, or probability of customer not leaving you is high. 1 means probability of customer leaving you is high. So the last output layer is, we have to think what is that we are getting. Okay, we are getting 1 output, so unit 1 is fine, and sigmoid, because we need to finally answer should be 0 or 1, so that's why sigmoid is used. But hidden layers, it's up to you to use it. That's it. Okay, and then how to calculate accuracy and things like that, you can use this, since it is a classification problem. You're using binary cross entropy. Okay, and metric that we're measuring is accuracy. Okay, and then you have optimizer. Now again, what is optimizer and what is loss? Okay, so optimizer specifies which optimizer to use in order to perform stochastic gradient descent. Okay, so so in neural network, okay, the optimizer that is used to calculate the error is ADAM. Okay, so there are other things like RMS Pro, Prop. Okay, but ADAM is what is mostly works well with ANN. So when you're ANN, your optimizer is ADAM. And loss function, okay, also talks about, okay, what kind of value you need. Okay, so if it is 0 and 1 binary classification, we use binary cross entropy, and you also have categorical cross entropy if it is more than 2 metric that you're looking at output. And finally metric. So we have discussed metric, right? Using confusion metrics, you have accuracy, you have sensitivity, right? So which all accuracy or metric you want, we can provide as a list. So you want accuracy, comma, sensitivity, okay, comma, whatever you provide, and you get all those values as output. So compile will compile or will create values which you can then compare and see the accuracy. Okay. So this is how you run a basic model. Okay. Now there's something called as batch and epoch, which we need to understand. What is batch and what is epoch? Now, when you have 1,000 rows, you cannot be providing all the 1,000 rows to it. Okay. So we create a batch of 64 or 128. Okay. Or whatever, you can create 100 batches of 100. So what it says is, okay, now if you look at here, if you have, let's say, 2,000 input rows, okay, and you create a batch of 500. Okay, so batch of 500, that means you're saying that I'm not going to take all the 2,000 at one go. I will take batches of 500, 500, 500 as input. So it will take 4 iterations to complete one epoch. Okay, so epoch is how many times you are passing the entire data set, both through forward and backward network. Okay, so if it is like ANN, it's only forward. Okay, so these are the parameters that you need to keep in mind for underfitting and overfitting, right? So you want something in between, right? You don't want underfitting values or overfitting. So that's why we need to repeat this experiment more than once. So epoch is how many times you are repeating. So epoch and hidden layers are different. Hidden layer means every data has to pass through those many hidden layers. But how many times are you running the model? Okay, how many rows are you giving in each time? So if you talk about batches is like at a time you are providing that many number of input rows, right? Epoch is how many times you're running the model. Of course, see, when you run model one time, you're not going to get best result. One time means your weight and bias is randomly selected. But second time, the weight and bias will be changed. Now, if you are running only one time, if your epoch is one time, definitely your answer is underfitting, not good. Okay, because randomly it has selected weight and bias, you're not going to get a good result. If you're running epoch 500 times, 1000 times, even 200 times, very likely you have gone into overfitting. Okay, it is changing the parameters so much that it works very well for the training data. So your epoch should be somewhere more than 1 for sure. Okay, and it changes based on the data. It could be 15, 25, 30, 50. You have to run and see how many epochs you need. Okay, and you won't be providing all the 2000 rows at the same time. So you define batches and you also define epochs. So did you understand? Batch is number of rows that has to go into the model every time, and epoch is how many times you are passing the same data. That means how many times you are repeating the entire experiment. So when you conduct an experiment, you don't do it just once. We will do it 3-4 times just to see that the output that you are getting matches every time. You do it once, it could be a mistake. Maybe you made some mistake, right? Then again, you repeat it, you get same answer. That means now you're more confident. You get third time, you get same answer. You're very confident that what experiment you have done makes sense. So here, okay, because the weights and bias are selected randomly, okay, so running it one time definitely will not give you a good answer. You have to go beyond one, right? You have to repeat this experiment again and again so that you get perfect values for weight and bias. Okay. So to fit the model, right? So far what we did was just to, create the algorithm, right? You are creating the algorithm. So to create algorithm, you need to create the object of whatever algorithm you are using. In this case, ANN. Then you have to, okay, you have to provide what? Layers, input layer, hidden layers, okay, and then output layer. Okay, each layer will have number of nodes and the function, the activation function. Once you are done, now you need to train the model. How do you train the model? You provide X-train and Y-train. And we are saying that provide data as a batch of 32. And I'm running 100 epochs. So if you have 64 rows, this entire experiment will run 100 into 2. Because batch is 32, you have 64 rows. That means 2 times you have to run it, right? And you're running it 100 times. So 200 times your experiment will run. Right? And batch size you can try with different numbers. Okay, doesn't have to be 32. You can try with different numbers. And this is how the output will look like. So it says epoch 92 by out of 100. Okay, so so this is, I gave epoch 100. So this is the screenshot when epoch is running 92 times. Okay, and you see you have loss and accuracy. This is what we said, right? Loss and accuracy. So you should see the accuracy value. Accuracy value will start increasing. After some time, it starts decreasing, right? So this is the optimum value. Very similar to what we did in our machine learning algorithms. Okay. So in this case, if you see 51, 56, right? And, so you need to keep track of accuracy because accuracy is what we are measuring, right? We give accuracy in our output value when we created that metric. When provided metric as accuracy, right? So you look at the accuracy value and then you decide, okay, what is the accuracy of your model? Okay, and then if you want to predict, you can predict it like this. So this is the input. Okay, then if these are characteristics of the customer. So if you provide these are characteristics to your algorithm, then this will give you the result. This will give you a whether this person is going to be with you or leave you, right? This is how you predict the model. Okay. So here we will stop. Okay. Tomorrow also we'll continue talking about deep learning. We'll talk about how to build this model. Okay. What is sequential API? What is functional API? Okay. And then we'll look at a couple of examples. Okay. And then we will also look at last will be how to fine tune your parameters. We call them as hyperparameters. Okay. So with that, we'll finish off our deep learning. So we'll see you tomorrow with this.
Yep.
Okay.